What's up, everybody? Welcome to System Crafters. I'm David Wilson, and today we're back with another entry in the Learning Emacs Lisp series, and we're going to talk about how to manage files and directories in practice with Emacs Lisp. So let me grab my screen here. So what are we going to cover today? Today we're going to talk about the many ways that you can interact with files and directories using Emacs Lisp. And there's a few different ways you could do this with the built-in user-facing Emacs functionality, like find file, dired, eshell, a few other things that you can use for these purposes. But at some point, you're going to want to automate some of these tasks with Emacs Lisp, because maybe you have a package you want to write, or maybe you just have some kind of repetitive task that you have to do frequently that you just want to make easier with Emacs Lisp. So today I'm going to show you a wide range of the functions that you have available, and then we're going to use them to write real code examples to follow along with the project that we've been doing so far in this series. But before we get into that, I wanted to explain one small piece of information, I guess, that maybe you know, maybe you don't know, but just we mentioned it quite a few times today, and that's symbolic links. So a symbolic link is basically an entry in the file system that points to a file or a directory somewhere else in the file system. Basically, it's used to make some file in the file system appear to be somewhere else. So for instance, if you have your a .files repository where you have all of your configuration files stored in it, and you want to make some of those files appear in your home directory, you would use a symbolic link to link your file in that .files repository folder to your home directory. So basically it just makes those files appear that they are in the home directory. And then any other program that tries to read those files will follow that symbolic link to get the actual content where it actually lives on the file system. So I just wanted to explain that right up front, because we're going to mention symbolic links quite a lot, and I didn't want anybody to be confused if you didn't really know what that means. So we're going to be continuing on with the project that we started in this series, which is basically a dotfiles management package for Emacs called dotcrafter.el. So in this video, we're going to add functionality to create symbolic links for your configuration files into the real locations where they belong in the home directory. So basically, you've created all these configuration files, you've added them to your .files configuration repository, and now you need to link them back into the home folder so that programs can use them. So to give you some more context on this, so far we've only been focused on generating .files from org mode-based configuration files. But the thing is, like, org mode configuration files are really cool whenever you have configuration bits like your Emacs configuration where you want to intersperse the actual configuration sections with maybe some explanation or maybe some higher level organization or links to other documents, etc. They're very nice for making a really nice presentation of your configuration. However, there's other types of files that you're going to want to include in your .files repository that don't really belong in org mode files. So you're going to have to deal with those as well whenever you have an org mode-based configuration. Basically, you need to be able to generate the configuration files from your org files, but then also you need to link the files that come from just a normal folder inside of your .files repository. So we need to add a way to do this automatic linking of these extra configuration files into the home folder, since we can't use org mode to just generate them directly into the home folder. So what we're going to do is write that code to mirror those configuration files using symbolic links and see how far we can get with that. And by the end of this episode, we are going to have an actual fully working .files management package. So it will be able to generate your configuration files and link all of them basically into your home folder. So we're finally getting to a point where the code that we're writing as a result of this series is actually going to be useful. And I'm intending for people to actually download and use this package for their own .files management, basically. So we're going to be using the dotcrafter.el repository. You see a link here. It will be in the show notes that I'll upload after this episode is uploaded. You can go there. You can start the repository. You can follow the instructions there to pull down the package. It isn't in Melpa yet, so you have to follow the instructions there if you use straight.el or just basically clone the repository and add it to your load path. And then also I have a link to the starting point of the dotcrafter.el Lisp file that we're using as the basis for everything we do going forward in this episode. So those are definitely a couple links that you're going to want to look at as you follow along. Okay, so let's get into the main topics, which are basically how do you deal with files and directories. So the Emacs has a lot of functions for managing the paths to things, like files or directories. And a lot of what you'll be doing is resolving paths for files and directories. And many of those functions are going to be using the current directory as the basis for doing path resolution. So it's really important to know about the default directory variable. This is basically a variable that contains what you would consider the current directory for the current buffer. So if there is a buffer open that corresponds to a file, like for instance, this one I have open right now, Emacs Lisp 06.org, the default directory variable is actually going to contain the directory where that file lives. So if I were to go to this default directory here and use Control-X, Control-E to evaluate that, you'll see in the echo area that it says home David Will Notes Streams. So basically, it's going to give me the directory where this file lives. Let me actually turn on keycast mode so you can see what I'm doing here. All right, so then other buffers that are special buffers like the scratch buffer, etc., also have a value for default directory, but the value for that really depends on a lot of things, whether it's been changed by some other code, or in the case of the scratch buffer, it's going to probably be the directory where Emacs was launched from. In my case, I'm launching Emacs as my desktop environment, so I believe that if I go to the scratch buffer, and then we look at the value of default directory. I'm typing this into the echo area down below, the mini buffer. You'll see that the value that gets returned here is the home directory, basically. So we started Emacs from the home directory. So default directory for the scratch buffer is the home directory. So keep that in mind. Every buffer will have a value for default directory, and it might just be the home directory if it's not a normal file buffer. You can also change the default directory if you want to. So if you're in a buffer and you want to make the default directory be something different, you can easily just use setq to change that. In all these sections, I'm going to include links basically to the actual Emacs or Emacs Lisp manuals where all the stuff is described. So definitely take a look at those if you want more information. All right, so at some point, you're also going to want to manipulate file paths if you're automating any kind of file operations in Emacs. Usually what you'll be doing is trying to grab different parts of a path so that you can build a new path based on those parts. So basically, in our case, if we're trying to get the location where a particular configuration file should live in the home directory, we're going to have to do some calculations on the path inside of the dotfiles repo to generate that new path. So there's a lot of functions you can use for this purpose. So in Emacs, file paths are considered to have two parts. The directory part, which is basically all the pieces of the path leading up to the file name, and then the non-directory part, which is basically the file name and the extension. And obviously not all paths will have a file name. It may just be a directory path, so it may just only have a directory part. So all of the functions you're going to want to use for this purpose, basically resolving paths, are going to start with file-name or file-name. So it's very easy to find if you're looking them up in describe function, or do they even show up in MetaX? Let's see, file-name. Yeah, I don't think they show up here. But in describe function, you'll definitely see all these if you type in file-name. We're going to take a look at all of these right now, but basically they're all just functions for getting different parts of the file path. And also one thing to note is that the file paths you pass into these functions don't actually have to exist. You can do calculations on paths that don't exist. It's basically just using the logic of paths and how they're constructed rather than actual locations on the file system. Okay, so first of all, for all these examples, we're going to use buffer file name. If you remember from the previous episode, we learned that buffer file name will give you the name of the file that the current buffer corresponds to. So if we were to use Control-X-E after this buffer file name, Control-X-E, it will tell us in the echo area that this is the current file, Emacs Lisp 06.org. I'm going to run this file name directory function to see what we get out of it. So Control-X-E there, and it tells us the directory where the file lives, which is home David Will Notes Streams. So now you can get the non-directory part, which is the file name, like we mentioned before. If we execute this part, we get Emacs Lisp 06.org. If you only want the file extension, like you're trying to determine what type of file you're looking at, you can use the file name extension function, execute that, and you just get org. You don't get the dot that comes as part of the extension. You only get just the letters for the extension itself. So that's kind of helpful. You don't have to do any extra processing on that to understand what type of extension it is. Also, there is the file name sans extension, which is basically all of the path leading up to the file name without the extension on it. So if you execute this, you can see that we get everything all the way up to Emacs Lisp-06 without .org at the end. So that can be useful if you want to do some, basically convert that file name maybe into a directory or maybe attach some suffix to it, etc. File name base will give you everything about the file without the directory and the extension. So if you just want the name of the file without anything else, then file name base is what you're looking for. And then file name as directory will take a file name and convert it into a directory name, which basically just means attaching a slash, which is the right way? That one? Yeah, I don't know. Attaching a slash to the end of the file path. In Emacs, Emacs will make the distinction between a directory and a file using the slash at the very end of the string. So keep that in mind. In some functions, it does matter whether you have a slash at the end of the path or not to determine whether it gets treated as a directory or not. So definitely keep that in mind. So if I already ran this one, so we saw, oh no, I haven't run it yet. So now you see that basically, it's like I said, it just attaches that slash at the end to basically turn it into a directory name. But in many cases, you don't want the extension to show up in the directory name. So if you want to, you can use that file name sans extension that we saw before to rip off the extension from the file path and then use file name as directory. If I execute this, you'll see now it's Emacs Lisp 06 as a directory. So we don't have that .org extension anymore. All right, so now that we know how we can build new file paths or extract the pieces of file paths, the next thing you're probably going to want to do is resolve file paths that you're constructing to make sure that they correspond to actual locations, or at least can be calculated. I mean, maybe it's a file path. Well, these won't actually tell you whether the file exists or not. It's just basically like, actually, if you have a piece of a path and you want to add it to another path to make it a full path, then you can use these functions to do that. So there are a couple functions that will, or there's one function that will tell you whether a path is absolute. That's the file name absolute p function. And if you remember when we talked about maybe in episode 2 or 3, we said that anything ending in -p is a predicate, which basically returns t or nil based on whether the thing it's checking for is true or false. So in this case, it will tell you whether the file name is absolute, meaning it contains a complete file system path. So basically like home/davidwill/whatever. Basically, it has to have a full path. It's not a relative path that begins with a dot, or a dot, basically. And also, relative paths could just be the name of a directory inside of another directory. We'll get into that in just a second. So, file relative name is a very interesting function that is very useful. It will give you the path of a file relative to another path. So basically what that means is if you have a full path and then you have another full path, you can basically compare those two paths and then get the relative path between them. So this can be useful whenever you want to see where one path lives compared to another path, and then use that relative path to generate yet another path. So we'll show how to use that in a minute, because that actually is very core to the process that we use in this in the package that we're writing. And then the expand file name function will return an absolute path for a relative path, and it may either do it based on the current directory using the default directory variable value, or you can give it that base path to use for the expansion, basically, so that you can basically say, I have this relative file path, I have another path, let me just put those two together and resolve that to be a normal file path. So let's look at a few examples here. We're going to look at the file name absolute p first. And for buffer file name, if we look at the actual result from that again, we execute this, we'll see that, yes, this is actually an absolute file path. And if we run this through file name absolute p, it will return t. It may be hard to see down here, but basically it returns true. Now, if we give it just the name of a file, that's not an absolute path. And if we execute this, we're going to receive nil, which is basically what we expect. We don't have an absolute path here. And also, like I was poorly trying to explain before, if you have a relative path, which is basically like a directory, a plain directory name / something else, that also is not an absolute path. At least in Unix-based systems, to have an absolute path, it has to have a slash at the very beginning. On Windows, it would be like a C:/ to say which drive the file is on. So in this case, we execute that and it returns nil because that is not an absolute path. So now let's look at the file relative name function. So what we're going to do is we're going to resolve the current file path basically for this buffer against the notes folder. So we know that this file is under the home folder / notes folder. So we're going to see what it returns when we resolve the relative name of this file based on the notes folder. So when I execute this, it actually returns streams / Emacs Lisp 06 because since this file lives inside of the notes folder, it just gives us that subpath under notes where that file exists. So if you try to do the same thing with a directory where this file does not exist, you will get a different type of path, which is basically a navigation path that will put you in the right place. So this file does not live under the .dotfiles folder in my home directory. So when I execute this, you'll see that the result is ./notes/streams because we basically have to go down a level in the file system and then back up to the notes folder to get there. And if you want to look at the way my file system is organized here, you can see that here we have .files. Let me just get back up to the top there. So we have .files here. This is in my home directory, and then notes is basically right here. So they're peers on the home directory, and that's why you can see that the result has just one ... because it only has to go down one level and then back up to notes, and then it can find that file using a relative path. So if we want to expand a file name in the current directory, we can just use expand file name with only one parameter, just the path we want to expand. Control-X, Control-E will give us that full path from the current directory. We can also expand a file path that doesn't exist. So we're going to use our current file name, but we're going to try to expand that from the .files folder. If I use Control-X, Control-E, we'll see it gives us the full path to this file in the .files folder, even though it does not exist. So this can be useful for finding the location of a file where it might belong, even though it doesn't exist yet, in case you need to do some operation to like maybe move a file there or create a new file, etc. One last thing that we don't really use in this episode, but it might be useful to you if you do a lot of path manipulation, is what about resolving paths containing environment variables? So if we try to resolve the home environment variable inside of expand file name, what we'll see is that it doesn't actually resolve it. It just literally puts that string into the path. There's a different function you can use called substitute in file name, which will do that substitution of environment variables. So if I were to execute this, it will give me home/davywill/.emacs.d because it actually is able to get the value of the home environment variable and put it into this path. So this a useful thing to know. Maybe you won't have to use it very often, but it's good to have in case you do need it. All right, so we're going to go into our first example. We're going to try to resolve the destination path of a configuration file that lives in the .files repository. So we can use a few of the functions that we've discussed so far to find where a file inside of the .files folder should be linked in the home directory. And basically the process we need to follow is we need to resolve the relative path of a file under the .files folder relative to the .files folder. So we basically just need to find that segment of the path where it lives inside of the .files folder. And then we need to resolve that piece that we got against the home directory. So we can basically just make it move that path into the home directory, basically. So for example, let me just give you a clearer example so you understand what I'm saying. So let's say that at the location where we store our configuration files in the .files folder is .files/.files. I know it's a little bit confusing, but that's the way I named it. So if we want to resolve this full path to this emacs.desktop file to get the relative path, what we really want to see is this .local/share applications, because we were trying to basically take this whole .files part off. And then we can resolve that into the home directory. So basically just add the home directory onto that. So we're trying to go from this path to ultimately this path so that we know where the destination of this configuration file would be. And the reason why we're doing this is because we're basically trying to take a single file structure inside of the .files repository and just mirror that directly into the home directory so that it's much easier. We have a standard approach for managing these files that are inside of our .files repository. Okay, so to accomplish this, we're gonna create a couple variables that hold a specific subpath in the .files folder where these linked configuration files will live, so that they're easier to manage. And then we're also gonna have a variable for the output directory. Now, in most use cases, this is just gonna be the home directory, but for testing purposes, it's nice to be able to say, well, instead of putting the files in the home directory when we do the symbolic links, let's put it somewhere else so we can just sort of see what the behavior would be if we actually ran this for real. So I've added an extra variable for that. And then we also have, let's see, is that the same thing? Oh no, I'm sorry. This is the .files folder. So this is something we've already seen in the series. So let me just evaluate this one. I'll evaluate these two also. So this third variable is actually the one where eval region. Okay. The third one here is the one where we basically say which folder is a subfolder inside of our .files folder where these configuration files belong. So the assumption I'm making here is that you don't want all of these linked files cluttering up the root of your .files repository, because either whenever you're showing your .files repository on GitHub or some other Git repository site, maybe you don't want all those files in that main listing on the home page of your repository. Maybe you want them in a subdirectory so they're not, right there visible in your face. So the idea here is that we have a special directory inside of the .files folder where all of our configuration files that need to get linked will live. And the thing that you have to keep in mind here is we actually have to resolve this against the .files folder every time that we need to use it. And that's why we create this the dotcrafter resolve config files path function, which I'll describe in just a second. So first of all, I've defined these variables, but I also want to set them to be something different for the purpose of demonstration here, because I don't want to destroy my own configuration setup right now. So I'm going to set these. I'm basically setting them to folders inside of the dotcrafter repository. Now, you might want to take a look at the files that I've added there, because I actually do have basically an example folder that has an examples configuration .file folder basically that you can look at with a couple of org files, and then a .files folder that has some other configuration stuff in it. So we're using this as an example basically of how all this functionality is going to work. All right, so now that I got those set, let's actually talk about what the resolve config files path function is going to do here. So we're going to call the expand file name function that we talked about, and we're going to give it the dotcrafter config files directory, which is this files path that we saw before. Now, the thing here is that we can't just expand that because it's going to be expanded against the current directory. So we need to use the second parameter, as we mentioned, which is the dotcrafter.files folder, to actually get the right path for that. So if we look at the value of dotcrafter config files directory, I evaluate this, we see the string .files down in the echo area. Now if I execute this little piece here individually, Control X, Control E, we'll see that it evaluates the whole thing to the path that we set here at this line, where we basically say that the example folder here is the .files folder. So if we evaluate this one more time, we basically see that the whole folder / .files. So now we have that folder that is supposed to contain all of our configuration files that need to be linked to the output folder, basically. So we made this into a function because we have to do the same expansion a few times, and it's better to do it with a function rather than copying the same expand file name code everywhere, because you're going to forget to do it at some point. When I was writing this code, I forgot to use it, and then I had problems. So better to just keep that in a function. Okay, now after all that preamble, we're finally at the function that is the example that we're going for right now. This is the example resolve config file target function, and it takes in a config file path that is supposed to live in that config files directory. And then we're going to try to resolve that to the output directory where the actual home directory is basically supposed to be. So let's look, we're doing some nested code. You're going to see a lot of nested Lisp code here. So I'm going to try to go inside out whenever we talk about these things. So here we are expanding the file name of the config file. So just in case, for whatever reason, someone gives us a relative file path, we want to expand that to be an absolute path to start with. And we also want to resolve that config files path, because what we're going to do is pass both of these into file relative names. So like I said, we need to find the relative path of the config file relative to the config files path inside of the repository. So this is going to give us that relative path, and then we can expand that relative path relative to dotcrafter output directory. So we're basically just converting from that absolute path config path under the config files folder to a relative path, and then we're re-expanding it back to the dotcrafter output directory, basically like we described before with that example that I showed you. All right, so now that we've got this, we can show this example where I am going to, actually that file might not exist yet, so let's try it and see, and if it doesn't exist, we'll find another file. But we're going to try to resolve this whole path to emacs.d/init.el inside of that folder. So I'm going to run this, Control X, Control E, And now it's going to give me the path under this demo output folder. So basically it was able to resolve .emacs.d/init.el from the .files folder to the demo output folder. So in practice, this would actually be from our .files folder /.files to our home directory. So that's the first step in what we need to do to basically bring this functionality online. All right, so the next thing is some more basic checking stuff that we need to do. Checking if files and directories exist. So you're definitely going to want to do this at some point. The file exists p predicate function returns t if a file or directory exists, or nil otherwise. So we can check to see if my .files/emacs.d folder exists. I run that code, it returns true. But there's a folder here that I'm looking for called foobar, which doesn't exist. And if I execute this, it returns nil. So it's a very simple function, does what you expect it to. However, it may not work for other things like symbolic links, and we'll talk about that in a little bit. There's also a few more functions you might want to use to check, like, let's say if the user has access to a file, whether the file is readable or writable, etc. I'm not going to show examples of those, but if you want to learn more about those, definitely check out this this link to the Emacs Lisp manual about testing accessibility of files. These can be pretty useful if you need to do more advanced kind of file operations. Another thing that's very common that you'll want to do is create directories. And you've probably come across this command before if you've tried to create a file using find file inside of a directory that doesn't exist yet. It will basically prompt you in the echo area to say you need to call make directory to create this directory. So this make directory command can be used both interactively and in Emacs Lisp code. So it's basically the same function, just used as code in Emacs Lisp. So the first parameter is the path to the directory that you want to create, and the second is an optional Boolean, you don't have to pass it, which determines whether any missing parent directories for that path also should be created. So sometimes you're going to try to create a directory that's in a subdirectory path where the parents don't actually exist yet. So this second parameter, if you set it to true, it will create everything. So if you've ever used the makedirp command in Unix systems, it's basically the same thing. It just creates that whole tree structure all at once. The other benefit of passing t as the second parameter here is that it will not throw an error if that path doesn't exist, or if it already does exist. So if the path exists and you're trying to create it, it won't return it, it won't throw an error. So it could be useful in some cases for that. All right, so let's try to make a few directories here. I'm going to try to make this local share foobar directory. So I'm going to execute this now, and it returns nil, but it actually does mean that it succeeded because it didn't throw any kind of error. And if we go look it up, we can actually see in local share foobar. So foobar is here now. We just created it. So if you try to create the same directory again, it's going to throw an error and tell you that the directory already exists. So if I run this, we're going to get this backtrace window that pops up that says file already exists. So at least it's pretty obvious what happened there. And like I mentioned, if you pass t as the second parameter and execute this, it won't throw an error even though that directory already exists, because basically you told it to just be quiet. So then we can also try to make a directory in a nested path that doesn't exist. So I'm going to try to make this local share hello system crafters path. If I execute this, it will complain that the parent directories, well, basically some part of this parent directory path doesn't exist yet. So like I said, you have to pass t as a second parameter to make that get created all the way. So I'm going to use Control-X, Control-E, and now it should be created. We can go back and validate that by looking at the local path, and then share. I think there's a hello. I have to refresh this first. So hello system crafters. So now it basically created all of those under that whole file path. So that's going to be really helpful for us as well as we move ahead. So now we've made it to our next example. And this one is going to require a little bit of explanation, because what we're trying to do is create expected directories before we start creating symbolic links. So when we start creating these symbolic links into the home directory, one thing we'll have to be careful about is creating symbolic links for paths that are too close to the home directory for certain directories. So especially for commonly used folders like .config or .local/share. So these two folders in particular are used quite a lot, and they're sort of a standard in Linux and maybe other Unix-based systems for configuration or for shared files from all applications. So let's say there's two scenarios to think about. One is you haven't been doing any kind of symbolic based configuration file management before, and you've got a complete .config folder that has a lot of different folders in it for different applications you've used, you run this code and it will just happily link whatever stuff you need that to go into the .config folder with no problems. However, the other case is if you've just reinstalled a system or installed a Linux system from scratch and you don't have a .config folder that's been populated yet, maybe it doesn't even exist yet, then if we start creating a symbolic link to .config to live inside of our dotfiles repository, then any new configuration files that get created are going to show up in our dotfiles repository because of that symbolic link. And then when we try to do git status on our dotfiles repo, we're going to see a bunch of files in there that we don't want. So then we're going to have to start editing our git ignore file to make those files go away. It's just going to be a major headache. So the solution in this case is to make sure these directories already exist. We're going to create them in advance if they don't already exist, because we want our algorithm for creating symbolic links to be very simple, to not have to think about this case. So we'll pre-create these folders so that when the symbolic link algorithm runs, it just blindly just puts symbolic links where they belong. And since those directories already exist, we don't create symbolic links for .config or .local share. We'll create symbolic links to things inside of those directories. So hopefully that makes sense. Basically, the point is that we're just trying to avoid doing something that will be annoying to the user in the future. All right, so we are going to have one more new variable here. This is the dotcrafter ensure output directories variable. And this is a list of strings basically for the names of folders inside of the output directory or in the home directory that we need to pre-create before we start making symbolic links. So I'm going to execute this. And then we have this very simple function called example ensure output directories, which just goes through this list. It resolves the file path against the output directory and then creates that directory. And it also will create any parent directories. So we're basically calling make directory with a T parameter in the second position so that we force all the parents to be created. And also if the directories already exist, we don't get an error, which is a great property to have here because in a lot of cases, .config will already exist. So we don't want an error to be thrown in that case. So we use expand file name here to expand the directory. We're doing a loop over ensure output directories, and then we're expanding each one of those against output directory, and then just making sure all of those are created. So what I'm going to do here is evaluate that, make sure it's there. Let's double check really quickly what's already in our output folder. I might need to delete it so that we can see it being recreated from scratch. So let's open up dired for the projects code dotcrafter folder, and then we'll go into demo output. There's some stuff here, so let me just let me delete this folder. Let's see if that works. Hopefully it'll work. I'm going to recursively delete that. Not here anymore. All right, so now we're going to go and run this example ensure output directory. So I'm going to use Control-X, Control-E. Everything's fine. Let's now go back to that folder. I probably should have kept that buffer open. We're going to go back to dotcrafter.el, and we'll refresh this. Okay, so it didn't actually create it, which is interesting. Let me double check what's going on here. So let's just check what the expectation would be here. So this variable is set to, oh, okay, we got problems with helpful. Sometimes helpful doesn't like to use org mode buffers. Invalid read syntax, that's really interesting. Okay, let me check. Let me try to just run this directly here. How about that? Dotcrafter output directory. Okay, so that's set to dotcrafter. Oh, okay. I did the directory names wrong. That's why this is not working. Okay, cool. So let me just jump really quickly back to, was it the previous example where we set those? Okay, yeah. Sorry about that. I had to put .el in these paths. That's why it's not working. Okay, so I'm just going to evaluate these two. And they should be correct now. Okay, that looks right. So now we'll jump right back ahead. And then we're going to try to run it one more time. Control-X, Control-E. Okay, it doesn't give any error that time. So now let's jump back over to the projects code dotcrafter.el folder. Now I can see they actually did create that dotcrafter folder if you notice that in a split second. Refresh this folder. There's demo output. And then we show hidden files. So .config has now been created. And then .local has also been created with the share folder in it. So that code does actually work. We just had to make sure that the variables were set to the right things for that to have the right effect. All right, so next thing is that we're going to learn how to list files in directories. This is a pretty fun one because it does a lot of work for you. You don't have to really do a lot of work to do listings of files. And a lot of languages, you'll have to do some kind of extra work to walk the file tree, but Emacs makes it very easy for you. So there's two functions for this. One is directory files, and the other is directory files recursively. And based on the names, you can just tell one of them basically lists files in a single directory, and the other one will do a recursive walk of all the directories to get all the child files there as well, which is very useful for us for the things that we're trying to do. All right. So we're going to look at a lot of different permutations of the arguments here because there are a few different arguments for both of these. I'm not going to go through everything, but I'm going to try to give you as much as might be useful to you. So the first one, directory files, and we're going to look at my .files folder to see what files get returned here. So Control-X, Control-E, and we get a lot of different files here in the echo area. If we were to go to the message window, well, actually, it still truncates all of that, but there's a lot of files there. So there's a lot of things you won't see because there's many .files in that folder before we even get to the org files. Now, the second parameter, if you set t, so everything after the first path is optional. So everything else we're going to look at now are optional parameters. The second one is a true or nil value, a Boolean value, which says whether full file paths should be returned. So what we saw before was just file names, but now maybe we want to see the full path. So I'm going to execute this function call. And now we're going to see all of these same paths we got before now are qualified with the full absolute path where they live. Then you may only want to filter down the set of files to a particular pattern, basically. So what you can do is use the third parameter, which is basically a regular expression, but you can use plain strings as well. So now I want to look for all the .org files inside of my .files folder. So if I execute this, now we'll see desktop.org, systems.org, workflow, Emacs, mail, readme, etc. inside of that folder. So if you want to get really specific about which files you want to list, you can do that with that third parameter. The fourth parameter is about sorting of results. Basically what it says in the documentation is that this can be useful if you're going to do sorting of your own after, so you don't want to pay the cost of doing pre-sorting whenever this comes in. So that could be useful to you if you care. Also, to note about that third parameter, if you give it an empty string, it basically is like saying don't use any filter on the results. Then what is that? 1, 2, 3, 4, 5. The fifth parameter sets a limit on the number of results that come back. So in this case, I'm setting it to 3. So I only want 3 files to come back in the results. And as you can see, I executed it and only 3 files came back. I don't really know how many cases that's useful, but there must be a use case for it. All right. Next is the directory files recursively function. And this one is a lot more interesting because we can do useful types of queries on a complete file tree to find certain types of files. The difference here is that you are required to pass a filter parameter, that second parameter in this case. You can't just pass the directory. So in this case, let me just make an example where I don't use a filter first. Actually, no, that's not a good idea because it's going to run a long time. So let me not do that. All right, so I'm going to use this simple regular expression. I know this looks a little bit weird. We haven't covered regular expressions yet, but just bear with me. What this is looking for is for any .el file, so any file ending in the .el extension. If you use this .org, it could also work for .org files, but since .el is EL is going to show up in a lot of file names, and that's not .el by itself is not specific enough in terms of regular expressions to find files that actually end in .el, so we have to go with the full specification here. I'm going to execute this, Control-X, Control-E, and it takes a little bit of time, but then it comes back to us with all of the .el files recursively under my .files repository. We see a lot of files here from the Lisp folder, and then we start seeing things from straight .el's build folder as well, like this ACE window. So we know that it's going definitely somewhere deep in the folder hierarchy to get those. Also, you can use that empty string like I mentioned before. If I use Control-X, Control-E here, actually it doesn't return anything because that file doesn't exist on this machine. But maybe if I were to change it to something like .emacs.d/eshell. Well, that doesn't help because it's not recursive. Can't think of a directory that would be recursive. But anyway, Control-X, Control-E, and we'll get back all the files inside of that eshell directory. Let's see, what was the the third parameter. So there's a third parameter here. I'm going to just look up the documentation really quickly. Whoops, that's not a variable. Control HF. And what it tells us is follow symlinks. So that is, wait a second, hold on. Include directories. So that could be useful if you, so right now, directory files recursively only returns the names of files and not the full, not any other directory names inside of the walking of the hierarchy. If you do want both file names and directory names to be returned, you need to pass T as this third parameter. So this is not actually going to work, but maybe what if I just use the dotcrafter, let's see, is this going to work here? No. So dotcrafter / was it output directory, I think? Yeah, let's use that. And I'll execute this. And it will give me .config and then .local/share and then .local. So .local is an intermediate directory in this hierarchy, so it actually did give us that as well. So if we were to set this to, yeah, that's actually a better example maybe. If we were to set this to nil in this case, or not pass it, if I execute this, it's going to, yeah, it returns nil because it doesn't return any directories. So that's how you know that that's actually working in this case. Maybe .files directory is better. I know I'm wasting time here, but okay, let's not do that. Okay, so next thing is you can use a predicate function. So you can do an inline function or pass in a function, however you like, for the fourth parameter that will restrict the directory walking. So it will not enter any subdirectory unless this predicate returns true. So in this case, we will only allow the subdirectory of Lisp in this .emacs.d folder to be recursed into whenever walking the directory structure. If I execute this, we're going to see all the files from .emacs.d at the top level, but we're also going to see files inside of the Lisp folder because we allowed it to go into that folder structure. So if you want to restrict what folders that the recursion can go into, or maybe you want to exclude certain folders, you can do it with a lambda function here as the fourth parameter. And then the fifth parameter is about whether symbolic links are being followed. So in this case, this last parameter, if we say nil, it won't follow any symbolic links. Let me see if that does anything here. Yeah, so it won't follow symbolic links here. But then if I run it here, does it follow any? I don't know if this example is going to work on this machine. Okay, so it did work on this machine because there's a symbolic link to the config/geek/current folder. So, excuse me. So basically, that last one is useful if you do want symbolic links to be traversed whenever you're doing this recursive file walking. I know there was a lot of examples. Hopefully that was useful. All right, so now we're actually going to use this to find the list of all configuration files that need to be linked. So luckily this time we don't need to establish any new variables because we have everything we need up until this point. And what this function is going to do is use this directory files recursively to look at that resolved configuration files path. So we want to find all the files under this config files path. And we're not going to use any specific filter. So we're required to use a filter string here, but we're giving an empty string because we want all files to come back. If we were to actually run this ourselves right now, I can run this inline, Control-X, Control-E, and we'll see that inside of that example folder, there's a few files here that can be copied. So we're actually going to, I mean, that was a good enough example as it is, but we're going to run this function anyway. So we've used a let expression to save the value of this into, or to bind the value of this into a name called files to link, and then we use do list to basically write all those out. I'm going to evaluate this function, and then I'm going to run the function, and then we can look at the message output to basically see that for each of these files, so for the input file of example/.file/.config, blah 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 blah, that file would go to this particular output folder path. So we're resolving all of those input files that are in your .files repo, and then we're figuring out the path where they are supposed to go in the output repo. So this is going to be very helpful for the things we do next, because we need a way to know which files we're going to have to run through our linker function. Okay, so now we're going to talk about how we can copy, move, and delete files and directories. So you can perform common file management tasks such as these with a few different Emacs Lisp functions. And I've got some links to the manual here that have a lot more information in case you need to find all of that. First of all, copying files. There are two functions for this. Some functions work for both files and directories. Some have special functionality for just directories. In this case, we have two. So we'll use copy file to copy a file from my Emacs init.el folder. I think I made some typos here. To the temp folder. Oh, actually, what's happening? I think I'm losing. Let me look at the actual content of this because I think something's wrong. I don't know why org present is making these disappear, but something is actually happening, I think. Okay. I may have to restart that part. Let me just go back here. Sorry for the difficulty there. Org present. Okay. So I think this is going to work regardless of the fact that you can't actually see it. So look at the show notes to make sure you get the right syntax for these. What I'm going to do is copy my init.el file to the temp folder. So let me run this really quickly. Control-X, Control-E. Already exists. Yes. Okay. So this is a manifestation of what I was telling you about before. Can I turn off? Let's see. Org appear. Let's turn off org appear. Let's. I think org appear is causing the problem right now. So let me just do that. Org appear is a great package, by the way. It's just giving me a little bit of a headache at the moment. Okay. Anyway, maybe I should just take this out of presentation mode for this particular example. So. In this case, we're trying to copy init.el to the temp folder, but the thing is, if you need to copy the file to the directory, you need to put a slash at the end. This is what I was saying earlier about Emacs treats directories a different way whenever you have a slash at the end of the path. So in this case, what it thinks you want to do is copy init.el to a file called temp in root slash temp, basically. But what we want to do is copy this file into the directory called temp. So if we put the slash at the end and I execute this, it actually will put that file under temp. And if we go look at temp, hopefully this is not a major mistake to do this, but let's see, is there anything bad here? No, I think it's fine. We can see init.el now lives here in the temp folder. So that's where we're at right now. And also, if you try to use copy file again to copy the same file to the same location, it's going to throw an error because the file already exists. But then we can use the third parameter to copy file, which basically says if you pass true, then we'll just ignore it if it already exists. So I'm going to run Control-X, Control-E on that line, and it will just not complain because the file exists and we don't care. The rest of the parameters to copy file are all about preserving metadata, and at the moment, we don't really care too much about that, so I would recommend going and looking at the documentation for copy file if you want to learn more about all of these. As you can see here, there's like keep time, preserve UID, GID, preserve permissions. These might be useful, so definitely take a look at them just in case you need them. We can also copy directories. So what I'm going to try to do is copy this directory of .emacs.d/lisp to the temp folder. So let's try to execute this. So once again, it's going to complain to us because we did not use the slash at the end of the directory path here. So we need to use that slash to make sure the directory we're copying gets put inside of the temp directory. So I'll run it again this time, and now it will complete. And if we use dred, we can look at temp/lisp and see all of those files that got copied over. So if you want to copy the contents of the directory without the enclosing directory. So let's say we wanted to copy the contents of the eShell directory, but we don't want a directory called eShell to be created. We want the contents of that directory to be copied into the target path. What we can do is use the, let's see, this is the 1, 2, 3, 4, 5. This is the fifth parameter. And if we look at the documentation of copy directory, it tells us it's called copy contents, this particular parameter. So copy contents at the end of the list here. So basically, if you pass nil, it will copy the directory, including the directory name. If you use T, it will copy the contents of the directory to the output path. So in this case, I'm going to run this, and it's going to copy the eShell folder. And if we look at that using dred, we can see here that, nil. Interesting that it copied the contents. It didn't do exactly what I thought it would. Let's run this one and see what it does. Control-X, Control-E. Let's look at we're going to look at the temp folder/lisp again. Yeah, so it seemed to do the same thing in this case. I think the reason why is because I did not put a slash at the end. Let's actually verify that really quickly. I'm going to put slash at the end of this line and execute it and see what it does. Control-X, Control-D, temp/lisp. Okay, so interestingly, it's copying only the contents of those directories, but in theory, that's what that parameter is supposed to do. I might just be calling it wrong, so that's my mistake there. All right, let's jump back into the presentation since I think we're past the point where we're gonna have syntax issues. Okay, so yet again, another example. We're gonna continue building this functionality for the dotfiles, dotcrafter.el package. So as we continue building our configurations, it's likely that we're gonna migrate a configuration folder from our home directory into our dotfiles repository. So let's say we start using a new program, it automatically writes out some configuration files to your .config folder, and you're like, okay, I like this program. I want to keep the config inside of my .files folder and check it in the source control. So we can create a function that actually will take care of copying all those files over to your .files folder using the functions that we just learned about. So the process would be that we're going to have a function that allows the user to choose a folder to move into the .files configuration path. Then we make sure that the chosen file is actually located under the output directory. So we're basically trying to make sure that they're not copying some random file from their file system because we don't know where to put that in the end. We want to take a file from a known location in the output directory, i.e. our home directory. And then once we know that it belongs in the home directory, we can copy that file to the corresponding location into our .files configuration path. All right, so I'm gonna do a couple of copy directory and copy file calls here just to put some files in the right place for our example purposes. So I'm gonna copy my config/geeks folder into the output directory. And I'm also gonna copy my bash profile file over to that output directory. And if we go look at that really quickly, we can see that in the, demo output folder, if we refresh that, it has nothing in it. Oh, did I do the wrong thing again? dotcrafter output directory. Let me just double check the values of these. Once again, I'm being thwarted by this this issue. Demo output. So .files/.config/geeks, and that exists, right? So should exist. Otherwise, my system wouldn't be working. .files/.config/geeks. Yep, that exists. Copy directory. File name is directed. Let's just expand this and see if we can see what might be the problem. File name as directory, and we're going to copy that over to, .config. But you know what? That's really interesting that it didn't show up. I might have to use something else, maybe the shell, just to do this in case this doesn't work correctly. So projects, code, dotcrafter.el, demo output. Oh, sorry, folks. Sometimes I forget that I have to show hidden files here. Okay, so that goes into config, that goes into geeks. All right, everything's there as it's supposed to be. My mistake. It's been a long day, actually, so I'm making a little bit of mistakes here. All right, so the file that I copied also should be there. And now that I try to copy it again, it tells me the file already exists. That's also a good way to check. So we have these two files that are in the output directory, but these aren't actually in our .files repository folder at the moment. So we're going to use this functionality to move those files there. And let me just do one last check to make sure that those files don't exist in the example folder, because where we want to put these is the example folder. So here we have .files. That's the folder where we will try to move these. Under .config, geeks does not exist here. And also under this .files folder, the bash profile file does not exist here yet. So this is where these files will be moved once we run this code. Now, this function is a little bit more complex than the ones we've seen before, but don't worry too much. We're going to explain what it does. This is the dotcrafter move to config files function, and it takes an optional source path. And the reason why it's optional is because we are using an interactive function definition here. Maybe I can make it non-optional here. In fact, let's try it and see if that works. Maybe I made a mistake. So we're doing an interactive function that will prompt for a file or directory path, and then we're going to say that this is the configuration path to move. So if you call this interactively, it will prompt you in the mini buffer area, then you can go select a file. So that should make it pretty useful. Now, we're going to use a let star expression because we have a few variables to bind that depend on each other. So first of all, we're going to get the relative path, and we're going to use that file relative name function that we talked about before, because what we want to do is to resolve that relative path of the source file against the output directory. So we're kind of doing the reverse of what we talked about before. So before, what we did is we're taking a file from the .files config folder and resolving it to be in the home directory. Now we're going the opposite direction, where we're taking a file from the home directory and resolving it to put it into the .files directory. So we're going the reverse direction now. So after we resolve that, we store that into relative path. Now we're going to get the destination path where the file belongs in the .files configuration folder by expanding the relative path against our .crafter resolve config files path functions output. So that will give us that directory inside of our example/.files folder for the full path of where that file would exist inside of the home directory. And we're also going to set the same variable again, which seems a little bit confusing, but basically this is a way where you can set the same variable. You can basically replace the value of the variable in this let expression. So what we're going to do is trim the trailing slash off of the end, because what we want to do later is get the parent directory of that directory so that we know the right place to put it whenever we do the copy operation. So I'm using this string suffix p function to see if the path ends in a slash, because a directory could be a directory. If you use file directory p, it might say the directory is a directory even if it doesn't have a slash at the end. So in this case, we're looking literally for whether there's a slash at the end. And if there is, we're going to use the substring function to take that slash off of the end of the string and then store it back into dest path. If it doesn't end in a slash, like say for instance, if this is an actual file and not a directory path, we just return dest path directly. All right, so now we're going to do a couple checks just to make sure that the file is something we can work with. First of all, we're going to see if this is a relative path string. And the reason why we look for the string prefix of ... is that if it's not a path under the home directory or the output directory, then it's probably going to use ... to go out of that directory and then go to another directory. So we can just look for ... to see whether this relative path actually represents a file that doesn't exist inside of the configuration output directory. So if it does seem to be a path outside of that directory, we just throw an error. Also, if the file already exists, we can't copy it, so we will throw an error preemptively to say it doesn't exist. Now, throwing errors here is probably not the right behavior long term, because we need a better way to surface this situation to the user to give them an ability to deal with it. So we're just going to use errors for now, but later we might come up with a different kind of error handling mechanism. Also, what we're going to do is ensure that the parent directories exist before we move the file using make directory. So we're going to use the file name directory function to get the parent directory of whatever that file is that we're trying to copy to create its parents before we move any further. And we're going to use T here to make sure we don't throw in an error if it already exists, or we create all of the parent chain of directories before we do the next step, which is the rename file function. So, oh, you know what? I missed a whole section of stuff up there because I have it in all these different sections here. Renaming a file. You can use rename file to rename files, basically. I'm not going to run through all these now because we've skipped past it, but basically there's a few different permutations you can look at here for renaming files and directories. It works for both renaming literally a file to just a different name or moving a file. So rename file is pretty versatile in that it can do both renaming and moving. I also did talk briefly about deleting. Deleting is pretty straightforward. You can say whether a file gets deleted. Also, whether you could pass T as a second parameter before moving it to the trash folder. Then also, if you delete a directory, you may also need to pass T to say whether the contents of the directory get deleted. So my apologies for missing that before, but those are the functions you need to use for moving and deleting files. All right, so now we've gotten back to the point again where we talk about rename file again. So we're basically moving the file using the rename file function. We're taking the source path that the user passed in, and then we are moving it to the destination path that we've calculated based on the work that we did above here to get the relative path to put it into our .files path. So I'm going to execute this function definition, and then I'm going to use this function interactively to take one of those files that I moved over to that folder and then move it into my .files configuration. So let's just actually pull this back up into DRED to see what we're doing. Control-X, Control-D, projects code dotcrafter.el. We're going to go into this demo output folder because this is actually going to be the source of where we're getting the file from. I'm going to run dotcrafter move to config files. This is the function that we just defined. Now it's going to ask me for which configuration path to move. I'm going to go into my config folder here, and I'm going to select the geeks folder because this doesn't exist in my .files path yet, but I want to move it there. So if I press enter, it will do the moving. It doesn't really say anything yet, but if we go to the example folder and then look into files and look into config, Geeks is here. So now we actually have the Geeks folder moved over there. It was very painless. It's actually going to be something very useful for users who want to migrate their files into their .files repository. If we go back and look at the demo output folder, look at config, there's no more Geeks folder there anymore. It's basically an empty folder now. So that did prove to us that we were able to move that file. Now, what about we moved a directory? What about a single file? We can move this bash profile file as well. I'm going to use the same function, the dotcrafter move to config files command. I'm going to pick bash profile. Now it should be moved. If I refresh this folder, that file is now gone. And now if I go to the example folder, which is our .files folder, we'll see that bash profile is there. So that function was able to figure out where the file or directory in your actual home directory needs to go in your .files folder whenever it gets moved. So it can take care of that whole process for you. All right, so the pinnacle of all this is now getting to the point where we are talking about creating symbolic links. So using symbolic links, we're able to keep our configuration files in a local Git repo and then make them appear to be in the home folder, basically. And it's very easy to do this in Emacs with the make symbolic link function. And this function basically just takes the source directory, the target of the link, basically. So in this case, our .files folder /.config/geeks, and then the name of the link as the second parameter. So basically the place where the symbolic link will be created. So in this case, we're saying in our home folder under .config, we're going to create a link called geeks that points to this .files/.config/geeks folder. Now the third parameter is basically just to say if the file already exists, throw an error. If it's nil, and if it's true, don't throw an error. So it's basically the same things that we've been seeing before. But keep in mind, this function doesn't work exactly the same on Windows. Windows wants you to have an elevated process, basically running Emacs as an administrator before you can use this function. And even then, I think that it has some issues and may not work all the time. So just keep that in mind. On Windows, you may need another solution for this entirely. And once I make this dotcrafter package work on Windows, I'm probably gonna have to figure that out. So maybe I'll have some things to say about that in the future. Also, you can check if a file is a symbolic link or a file path is a symbolic link by using the file symlink p predicate function. In this case, I'm checking to see if my my home folder's .emacs.d folder is a symbolic link. So I execute that, and it returns actually the target of the symbolic link since this is a symbolic link. However, if I look at one of the files inside of that folder, the init.el file, if I run the same thing on that, it returns nil because that file actually is not a symbolic link, even though we followed through a symbolic link to find it. And lastly, you can use file true name to get the full resolved path of the symbolic or any file that exists under a symbolic link. So in this case, we are looking at that init.el file that itself is not a symbolic link, but because it lives in a path that has a symbolic link in it, it will resolve the whole path. So I'm gonna use Control-X, Control-E here, and it's gonna give me the whole path under my .files folder for that same file. So those things are very useful, and I think we're gonna use them here as well in the next example. So here is where everything finally comes together. Now we're going to write the function that creates all the symbolic links to the files in our .files folder over into the home folder. We're gonna implement a little bit more elaborate of an algorithm this time, but don't be intimidated by it. I'm gonna explain everything that it does. And basically, what it's going to try to do is create the symbolic links at the optimal level in the home directory so that we don't create a symbolic link for literally every single file inside of your .files folder. So if you've ever used GNU Sto, it has the same behavior. I'm basically re-implementing the same behavior where if you have multiple files in a folder that's being symlinked, it won't link all those files. It will just link the folder that those files live in. And if there's folders up the chain where more of the files are going to be symlinked, it will just take the higher folder than the ones that are below to link all of that. So there's a very simple algorithm we can use for that in this case, and I'll show you how that works. First, let me explain what the algorithm is going to do. So we're going to loop over all of the files in the dotcrafter config files directory recursively. We're going to use that recursive function to get all the files under that file path for files to be linked. For each of those files, we're going to break the path into pieces so that we can get all of the directories that lead up to the file name, because we're going to look at each one of those in order, basically, to figure out how we want to process all of them. And for each piece of the file path, we're going to check if that piece of the path exists. And if it exists, we're going to check if it's a symbolic link. And if it's a symbolic link, we're going to check to see if it points to the same path that we're supposed to be looking at. And if it does, we're all good. We don't need to do anything. Otherwise, if it doesn't exist, we're going to create a symbolic link in that location. So to give a more sort of graphical example of how this is supposed to work, let's say that we have this file path that we want to create a link for in the home directory. And we want to put it inside of the home directory under the .local/share/applications path. So if we break this path into pieces, what we're going to have is we're going to rip off the. I thought I had more parts of this, but maybe that was somewhere else. We're basically going to take this whole local path part off. We're going to resolve this so we just get this local share applications part. Then for each part, we're going to break this apart to say .local. We're going to look at .local first. We're going to check in the home directory to see if .local exists. So in this case, yes, it exists. So we're going to go to the next part, which is share. We're going to check if share exists. So in this case, share, it does exist. So then we're going to go into the next part, which is applications. Here, applications does not exist. So that means, oh, okay, we have an opportunity here to create a symbolic link to that same applications path inside of our .files repository. So that's what we're going to do. We'll create that symbolic link, and then any files under that will also show up inside of the home directory under that same path. So that's how we optimize the set of symbolic links that get created so we don't create too many. So now let's look at the code. All right, so we're going to look at this line by line before we run it, because there's kind of a lot of things that it does. And there's two functions we're defining here. One of them is this link config files, which is a user-facing function that somebody will actually run, maybe even run it interactively. And then there is an internal function, and this doesn't show up right now because I think maybe org appear is making it go away, but there's two hyphens here to indicate that this is an internal function that handles linking a single file. So let's look at the main function first here, dotcrafter link config files. So this is an interactive function, and it's going to use that directory files recursively to grab all the files under our config files path. We've seen this pattern a couple times before already. And then we're going to save this into the config files variable. Now, before we go through the process of making those links, we're going to do that thing we saw before where we loop over all of our output directories we need to ensure that exist, and then try to make them first so that they're already there before we start doing symbolic links. Then we finally loop over the config files list, every item in config files, and then call this link config file function on each file. And we're using do list for the lists on both of these cases, just because it's very easy to use. Okay, now we'll look at this link config file function. So first of all, we're going to use the split string function to break apart this config file path into all of the parts that we mentioned before. But before we do that, we're going to use file relative name to resolve basically the local path of that configuration file relative to the configuration files path. So once we have that local path, then we can break it into pieces, and we're going to use that slash character as the delimiter that we use to break it so that we have each directory path individually as a list. And I think this T, basically what it does is it gets rid of any empty entries in case there's an empty entry in that list, so that we have only the actual path pieces that matter there. We're also going to define a variable called current path as nil for now, but we're going to set it later as we go through the list. And then we're going to use a while loop on this path parts variable that we just created. And what this does is basically allow us to look at every iteration of the path parts variable. We're going to keep taking items off the front of the list, and then once we finally get to an empty list, that list is actually going to be nil, which makes this while loop stop running. So as long as we just keep taking items off the front of path parts, eventually we'll get to nil, and then the loop will complete. So for each iteration, what we're going to do is create the current path using the first part. Basically, we're going to take the first part off that path parts list, and then we're going to save path parts with the remainder of the list. So if you remember in maybe the second or third episode, we were talking about lists and how you can use the car and coulter functions Car returns the first item of the list, and cdr returns the remaining items of the list. So in this case, we use car of path parts to get the first item off. So we're basically looking at, from the example we saw before, the .local piece off of the path. And then we concatenate the current path, if there is a current path, with the slash. So there won't be a current path at first. So what we're actually going to do is start that path using the beginning of path parts. So this is a little bit of a funky thing we have to do for the first iteration. So current path is nil to begin with. So in that first iteration, we want to have only .local be the current path. But then for every subsequent iteration, we're going to concatenate each part of that path back onto the current path so that we have the progressively deeper directories, basically. So this if statement accomplishes that in line. We're actually updating current path every iteration to have the progressive path that we're building there. Hopefully that makes sense. And then we update path parts to only contain the remaining items of path parts using the cdr function, as we mentioned before. So now, next step is to figure out whether the current source path can actually be linked to the target path. So we're gonna build the source path and the target path by using expand file name. For the source path, we're going to concatenate the config files directory with a slash to the current path. So we're basically going to build a path taking the config files path and the current path and put them together. So basically the config path /.local /share, whatever, basically. And then we expand that against the .files folder so that we make sure that we have the full realized path to that file in the .files folder. For target path, we expand the current path against the output directory. So we're basically just putting that same path fragment under the output directory. So now we have both the source path and the target path. Now, as we mentioned, we have to check to see if there's already a symbolic link there for the target path. So if there is one there, then we check the file true name, which basically tells us what the actual real file on disk where this links, to see if it's equal, basically the string equal function to check source path against that true name of that target path. If they are equal, that means that the link already points to the place where we want it to point to, so we don't need to do anything else. So actually what we'll do here to exit the loop, since there's no concept of a break inside of Emacs Lisp, we can't break out of a while loop. We have to do something to make that, that condition in the while loop return nil so that it exits. So what we're going to do here is set path parts to an empty list so that loop will now exit. However, if the symbolic link exists and it points somewhere else, what we want to do is throw an error because the path already exists. It's a symbolic link. It points somewhere else. We can't really do anything because we can't overwrite that link. So we have to stop basically. So if it's not a symbolic link at this location, what we're going to do is see whether it's a directory or not. So if it's not a directory, then it's also an error. Wait, let's see. Yes, if it's not a directory, it's, if it's not a directory, then we make the symbolic link in that location. So basically, if there's not a directory already in that location, then we can create a symbolic link there to whatever the file is. This also would throw an error. If we try to call make symbolic link and a file exists in that location, it will error, and we're sort of depending on that to throw an error here. There definitely could be some extra error checking being done at this point, but we just didn't add it because we don't want to make the code more complicated. However, so basically that's how we get to the point where we create the ultimate symbolic link, where if there's not something there already, we will just go ahead and create a symbolic link there and everything's good. And then the last thing we do after we create that link is that we set path parts to an empty list so that we exit the loop. Since we're done now, we've found the place to put the symbolic link, we've created it, we're done. So if we don't hit the path here, if it's not a file directory, then what we're going to do is actually go back to the top and then try the next directory inside of that set of directory listings. So if this whole block of logic does not evaluate, then we just keep going in the loop until the next path segment, and then we look again for the next place to go. I know that was kind of complicated to walk through. I hope that makes sense. If it didn't make sense, definitely leave a note in the comments and I'll be happy to try to clarify things. Also, come to the System Crafters Discord and we can talk about it more in detail there as well. All right, so I'm going to evaluate these two functions so that we can run them. Actually, no, maybe what we'll do is run them using the script that I prepared. I think that's a better example because we can do everything at once. Nah, let's just do it this way. Let's try it this way. All right, I'm gonna execute this, and then I will run dotcrafter link config files. Now, before we do this, let's just go one more time and look at our output folder. So what I'll do is projects code.crafter.el. I'm gonna delete the output folder, and then we're gonna see if it gets created as a result of running this. Normally you wouldn't delete your home directory to try this, but we're just gonna do it in this case and see what happens. So I'm gonna run dotcrafter link config files. And it didn't throw an error, must have worked okay. So let's go back to that folder and see what happened. So now if we refresh this, we have a demo output folder. And if we show hidden files, now we see we have a symbolic link for bash profile and for profile. For our config folder, we have and also notice .config and .local are not symbolic links because we pre-created those folders. So inside of .config, we have a symbolic link to geeks. We have one to xsettingsd, one to mymaps.list. And then if you go back and look at the local folder, share also is not a symbolic link because it already existed. But then if we look at this folder, applications is a symbolic link. So basically all that logic just created those symbolic links at whatever level was necessary to link the rest of the remaining file structure into that home directory, or in this case, the output directory. Let's see. The other thing that I didn't mention is that since I do have a couple of org files here that have their own output, like let's say the Emacs configuration file will write out a file to dotfiles/emacs.d/init.el, and then the desktop.org will write out a couple of files. One of them was that xsettingsd that we saw, and the other was the mymaps.list that we saw. So we got a couple examples of org files, demo org files here, and since I've already run the tangling of those at some point in the past, those are part of the output already. But let me just go delete those so that we see. We go into example files. I want to get rid of the init.el because we're going to do something next that will show how this is all going to work in practice. So I'm going to delete this emacs.d, and then inside of configuration, I'm going to delete these two because they're being generated. So let me delete those, execute that. Oops. All right, so now what we're going to do is go to the next step. Since we verified that the function actually works, we're going to go to the final step of everything here. So what we're going to do now is tie together everything that we've done up until this point in the series. So we're going to use the functions we've been writing in the last few episodes to make a new function called dotcrafter update dotfiles. What this is going to do is provide an interactive command that will first tangle all of your org files using the tangle org files function that we wrote into your output directory. Then it's going to link all the configuration files into your home directory. And then it's going to update the getignore file to ignore any of the files from your tangled org document output, so that whenever you make commits to your .files repository, only the files that are literal config files that live inside of the .files folder will show up there. So we're going to put all these pieces together now into one function. So I've evaluated this, and if I run it, dotcrafter update .files, then it's going to take just a second because we're doing some tangling first. But then if we go back to that directory, projects code.crafter.el, demo output. So let's see. Excuse me. I probably should have deleted that first, but we can see now that in the example folder, now it's the .emacs file, .emacs.d file has been recreated. These configuration file folders have been recreated. And now if we go to the output folder once again, we can see that they've all been symbolically linked. I can delete the demo output folder one more time and then run that update .files again. And then if I refresh, I see all of that is put back into place. So it worked one more time. And if I run that again, it won't throw any errors because everything we're doing is basically not making any changes as everything is already in the right state. So you can run this command as many times as you want to make sure that everything is up to date. So like for instance, if you sync your .files from your repository, like if you updated your configuration on a different machine and then you've committed it and pushed it, and now you're syncing it back down to another machine or your current machine, you can just run this command after syncing to get everything back up to date and in sync on your home directory. So we finally reached a point now where we've basically got a full end-to-end, excuse me, working package that can manage all of our org configuration files and all of the other files that are there in your dotfiles repository. So it's kind of cool. If you want to try all this out yourself, you can clone the repository, and I've got a little demo script there which will basically run through the same thing we just saw. If you just run this Emacs command in that directory, then you'll see all the same things happen again. So I'm really happy with how this turned out. I think it worked really well to get to a point where we have something that actually does work based on the things we've been talking about before. Excuse me. So what's next? I mean, now that we've got to a point that things are working, we should try to take it to the next level by creating major and minor modes for this package. So in the next episode, I'm going to show you how to create a minor mode to gracefully handle automatic org file tangling. And if I have time, I might actually talk about how to do that asynchronously as well, so we don't block Emacs whenever we try to tangle a file on save. And then in the episodes after that, I'm going to create a major mode to provide a basically like a user interface for this package so that you can see all your dot files and you can manage them in a more graphical way to make it a little bit easier. And then later, we're going to prepare the package to be published in Melpa. So I'm going to show you the whole process for how to take the code we've written so far and turn that into a full Melpa package that somebody else can install on their machine using use package. So I think it's gonna be a lot of fun, and thankfully my voice decided to die right at the very end after I did all that talking. I apologize, this is the longest video I think I've ever done. But hopefully that was useful. If it was useful, definitely leave a like on the video and leave a comment if you have any further questions about what we saw here today. And I'll be happy to answer it. And like I said before, join the Discord and we can chat about it more there too. All right, so before we go, I just want to say thank you to my sponsors. These people have decided to sponsor the work that I'm doing, making these videos about GNU Emacs, GNU Geeks, etc. And I'm very thankful to them for their support. Their support means the world to me, and basically it keeps me going. I mean, like, there's been times where I've been really sort of down and thought about quitting, and just thinking about thinking about the people who have, you know, put their faith in me by becoming sponsors. It really just made me want to continue because I didn't want to let them down. So if you're interested in becoming a sponsor of the work that I do here, definitely check out the links I have below in the description. I'm on both GitHub sponsors and Patreon, and also have a link to PayPal for one-time tips. With that, we're done with this episode for today. I hope that wasn't too long for you. Let me know if you thought so. But I think it was worthwhile to see all of that happen because we did get to a pretty useful result in the end. And you can go check out the dotcrafter.el repository to see all the code that we did here so that you can try it out yourself and maybe even start using it for your own dotfiles management. I'm going to start trying to do that soon too, just to see if it works well for me. So anyway, until next time, thanks a lot for watching. I hope it was useful for you, and happy hacking. Thanks a lot.